Problem number 17. In figure, a force P vector acts on a block weighing 45 Newton. The block is initially at rest on a plane inclined at angle theta equal to 15 degree to the horizontal. The positive direction of the x-axis is up the plane. Between the block and the plane, the coefficient of static friction is mu s, which is equal to 0.50, and the coefficient of the kinetic friction is mu k equal to 0.34. In unit vector notation, what is the frictional force on the block from the plane when P vector is minus 5 Newton I cap, minus 8 Newton I cap, and minus 15 Newton I cap? So in this question, we are going to find the frictional force for three different values of P vector. And here we place a block in an inclined plane at an angle of 15 degree. Initially, the block is at rest, and that block weight is given as 45 Newton. And there is a friction between the block surface as well as the plane surface. That's the reason they gave the coefficient of static friction and kinetic friction, which takes the value of mu s 0.50 and mu k 0.34. Now, what we have to do for getting the answer for the frictional force, first we have to frame the equation from free body diagram. So that means we have to draw the free body for this given figure. And from that free body diagram, we have to frame the equation. By using that equation, we have to find the answer for maximum static friction value. And then we have to apply the three different values of the P vector in that equation. And then we have to find the answer of the frictional force in unit vector notation. First of all, let's rewrite the given first. The weight of the block is given as 45 Newton. And the angle theta is 15 degree, and the static coefficient value is 0.50, and then the kinetic friction value, the kinetic friction coefficient value is 0.34. And now we have to draw the free body diagram for this diagram. As we already studied in chapter number 5 and also in 6, the normal force acting always to the perpendicular to the surface of the object. Here we have the block, so to the perpendicular of the block, we have the normal force, right? So this is the normal force acting perpendicular to the surface of the block. And then exactly in the downward direction, we have force due to gravity, which is nothing but the weight. So here, this force due to gravity, W, has two components. One is cosine component, which is W cosine theta, and then we have another sine component, which is W sine theta. So in this direction, you have a frictional force. So this is the free body diagram. That means the force acting on this block. So you have upward force, you have downward force, you have rightward force, you have leftward force. For finding the answer for the frictional force, first we have to equate the upward force. That means your normal force, so your upward force, which is equal to downward force, because straight to the normal force you have W cosine theta. So how we can write Fn, which is equal to W cosine theta. Likewise, we have to frame the equation for our horizontal forces, and you can see your friction force is in the positive direction of the x, and then there are two forces. One is P vector as well as W sine theta, which is acting in the negative direction of the x. So I have to frame the equation for this. Therefore, F of F, which is our friction force, which is equal to P vector plus W sine theta. So these are the two equations we are going to use for finding the friction force. Now the most important thing, while you substitute the value of the P vector in this equation, we have to take only the magnitude. Why? Because they give the value of minus 5 Newton. That means the block will be, the force acting on the block is towards the direction of the minus x. That's the reason they put minus. Apart from that, there is no meaning. Clear? So what I'm going to do, better we can just use the magnitude of the P vector, because here the sign only indicates the block is moving in the negative direction of the x. That's the reason let's take the magnitude of the P. Now what I'm going to do, first of all, I'm going to find the normal force, and then I'm going to find the maximum static friction value. Clear? So okay, so let's find. So I can just give the equation number. This is our equation number 1. This is our second equation 2. First of all, I have to find the normal force. Therefore, to find the normal force, Fn. So what we have to do? We have to use equation number 1 for finding the normal force. Which equation we have to use? Use equation 1. So what is our equation 1? Fn, which is equal to W cosine theta. Now I am going to substitute the value here. The value of the W is given here as 45 Newton in the question, and then the angle theta is 15 degree. So 45 multiplied by cosine of 15 degree. So let's see what's the answer. So 45 multiplied by cosine of 15 degree. I got the answer here as 43.47. What's the answer? 43.47 Newton. This is our normal force. So after I got the normal force, I have to find what is the maximum static frictional value. So maximum static frictional value is given by the rule mu s multiplied by Fn. So Fn we already got here. Mu s value already they gave in the question as mu s, which is equal to 0.50. So I have to substitute the value of mu s here. I have to substitute the value of normal force value here. By that, we can easily find what is the maximum static frictional value. So Fs max, which is equal to 0.5 multiplied by 43.47. So let's see what's the answer. So 0.5 multiply 43.47. I got the answer as 21.73. So I can write 21.7 Newton. This is the value of the maximum static friction force. Clear? Now what we have to do, we have to use the second equation for 3 different values of P. We have to find whether the block is sliding or not. So for that, I have to use the second equation, and in this second equation we have to substitute the value of 3 different values of the P one by one, and then we have to compare the answer with the maximum static friction value. Okay, let's rewrite the second equation, and after I wrote the second equation, I am going to substitute the value of P as minus 5 Newton there. So let's write the equation first. Clear? So what is our second equation? Our second equation, F, which is equal to the magnitude of the P vector plus W sine theta, and then we have to substitute the value here. So let's substitute our first value. What is the value of first vector? So here we have to substitute a minus 5 Newton I cap. So I'm going to consider only the magnitude of this value. So magnitude of negative, it's positive, right? So I have to substitute the value in this place. So let's see what's the answer we are going to get. Magnitude of minus 5 is 5 plus W value is 45 sine of 15 degree. So let's see what's the answer. So 5 plus 45 multiplied by sine of 15 degree. I got the answer as 16.65. 16.65 Newton, and we have to give the answer in unit vector notation, which is I cap, right? So after you substitute minus 5 Newton I cap, what answer we got? We got the answer as 16.65 Newton I cap. Now we have to compare the value of maximum static with this value. So here you can see the value of static friction value is greater. So that means our Fs max is greater than F of F. So if your static maximum value will be greater, then the block will not be slided, it will be at rest. So what answer you have to give? After you gave the force of minus 5 Newton I cap, what happened? Still the block is not achieving the maximum static value, which is not exceeding this value. So what we have to do? We have to write the block still at rest. Still at rest. Why? Because we did not exceeding the value of the maximum static friction. Okay, now what we have to do? Let's go for the second value of P. What is the second value of P? The value of second value of the P is minus 8 Newton, which is already given in the question. So I have to take the value of P as minus 8 Newton I cap, and then again I have to substitute the value in this equation. What is our second equation? Our second equation is f of which is nothing but magnitude of the P plus W sine theta. So here I have to substitute the value. So what's the value of magnitude of P, which is plus 8 plus 45 multiplied by sine of 15 degree. So let's see what's the answer. So I got the answer here as 19.65. What answer I got? 19.65 Newton and I cap. So this is the value we got after we gave the force value of minus 8 Newton. And what should be the value of the maximum static value, which we already found as 21.7, right? So here we got the value as 21.7 Newton. Again, your maximum static friction value is greater than the frictional force. So that means still the block is at rest. Why? Because we did not exceeding the value so far. So that's the reason the block is at rest. Now let's see, after we apply the third value of P, what is our third value of P, which is minus 50 Newton, which is already given in the question. So let's substitute the value of the third P vector value, which is minus 15 Newton I cap. Again, I have to substitute that value in the second equation. What is our second equation? Magnitude of the P plus W sine theta. So now the magnitude of minus 15 is 15 plus 45, a sine of 15 degree. So let's see what's the answer. So after I substitute the value, I got the answer as 26.6. I got the answer here as 26.65, and unit is Newton, and it is in I cap. Clear? So now we have to compare the answer with the maximum static friction value. So what is our maximum static friction value? The maximum static friction value is 21.7, right? Okay, so the maximum static friction value is 21.7 Newton. So now you can see our answer is greater than the maximum static friction value. So now the block is sliding. Now what answer you have to write? After you applied minus 15 Newton I cap, what is happening? We are exceeding the value of the maximum static friction value. So what you have to write? We have to write the block is sliding now. Clear? So once the block slided, what we have to do? We have to find the kinetic friction, because once the blocks start to move, the static friction is converted to kinetic friction, right? So the formula for the kinetic friction is Fk, which is equal to mu k multiplied by Fn, and mu k value already they gave in the question as 0.34. and what's the value of Fn? So we have to go back to the first part. We already found the answer, right? So what's the value of Fn? The value of Fn is 43.47. So I have to write this value 43.47 Newton. Now I have to substitute the value of Fn here. I have to substitute the value of mu k here. So let's see what's the answer. 0.34 multiply 43.47. So let's see what's answer I got. So 0.34 multiply with 43.47. I got the answer as 14.78. So 14.78 Newton, and we have to give the answer in unit vector notation, which is Fk. Clear? So why we found the answer for the kinetic friction? Because generally, if you got this type of question, we have to compare the answer with the maximum static friction value. For example, let's take part A and part B. In part A, the answer is not exceeding the value of the static friction, and also the answer for the B part is also not exceeding the value of the maximum static. That's the reason we did not find the kinetic friction, because you have to find the kinetic friction only after you exceeding the value of maximum static friction value. Clear? So that's the reason in the third part, you can see the answer. Once you exceeding the value of the maximum static friction, we have to find what is the kinetic friction value. And the most important thing I have to remind you again, why we take the magnitude value of P here. What's the reason? Because the value of P is given is minus. It's nothing, because they clearly mentioned in the question, the upside of the plane is positive X. That means the downside of the plane is negative X. That means the block is sliding towards the negative. That's the reason they give minus 5 Newton. So why we have to write minus again? Because it clearly shows the question is related with the one-dimensional motion. Am I right? So we can consider the magnitude. That's the reason here I took the magnitude value. So please don't substitute the value of P as negative. We can just substitute the magnitude of the P value. That's more than enough. Clear? So these are all the answers for this question. So if you got any questions like this, you have to do very carefully, and you have to compare every time. You have to compare the answer with the static. Once you exceeding the value of the static, find the answer for kinetic friction. That's it. This is the answer for this question. Thank you.